Okay, so we need to solve this problem, which is basically the dynamics of lifting a box of bricks off of the ground and how long it takes it to get up to its maximum speed. So let's look at this problem and see what our key parts are. So if we come in here, here is our motor. And then we're picking up a box of bricks. Oh, look, see, it has a diameter of 20 millimeters and it's 100 kilograms. And we're basically putting 90 volts across the motor to get our speed up. Okay, so let's see what this looks like. Now we're going to do this in Simulink, so we're going to break it up into one piece at a time in the Laplace domain. So let's start with our input. Let's start with our basic block diagram. So we have this pulley and it has a radius of 10 millimeters. And then we come down here and here is our box of bricks. And so it has a force of M times G. Now we don't want to do this in force, we want to do this in torque. So we're going to be dealing with how does this weight affect this pulley system. So our load torque is going to be equal to M times G, which is the force, times our radius. Okay, now in order to start this off, we're going to have our motor, which is going to have a motor torque. Okay, and now let's start with our motor torque because you see our input is the 90 volts. So let's start with our motor. So we have a 90 volt step, which we'll just call VA. And this has an RA and this has an inductor. Now we're doing this in the Laplace domain, so this becomes S times L. And then we have our back EMF, which is KE times omega. Now, we're trying to get our motor torque. So in order to get our motor torque, we're going to start by figuring out what the current is, because we have the T, our motor torque is equal to KT times omega. Oops, not times omega, times our current I. So we need our current. So our current is going to be equal to VA minus our KE omega divided by this RA plus SL. Okay, so let's start with this, but then we're going to break this up. You see I have an input here subtracted by that. So what we really have is that my current is equal to VA minus KE omega times this transfer function, 1 over RA plus SL. Now, we are so we're doing this with Simulink, so we need to see what our inputs and our outputs are. So our input is our step voltage, VA, and our output is really going to be equal to omega, or if we wanted in terms of velocity, then we have the velocity is equal to omega r. So now let's go over to Simulink when we get started, because we're really going to start with our input. So this is our input. So we're going to start with our input and subtract off some piece that is fed from our output. Okay, so let's go over to Simulink. So we're going to come over here and we are going to click on our Simulink button, do a blank model right here, and we're going to start with our input. So we type step. Here is our step input. So the step time, we want this to turn on at time 0. The initial value is 0 and 1. So the first thing that we want is we want a 90-volt step. So we're going to take that and multiply it times a gain function, and that's going to be a gain of 90. Okay, so then this is our input point right here. And so you see that we want to subtract off some piece of our output. So somewhere over here, we're going to have our omega. And so we have to subtract that off from here. So we're going to come in here and we're going to do a sum terminal. And you see with this sum terminal, I can either add or subtract. So I want one positive and one negative. So here is our negative. So this takes in our VA right here and is going to subtract off some piece. Well, our output is going to come over here and get multiplied by our gain. So we need another gain term. And okay, so this is our gain element, but this is coming from our output over here. So we kind of need it to go the other direction. So I'm going to click here and I'm going to right click and do a rotate flip. And then we want to flip block. Okay, so then this is our KE. And we'll put in its value later. So we're going to go and draw that to here. So then this value right here, if I click on this, I can and I'm going to call this KEW. And this point right here, we can call this VA. Okay, so then we're going to take this, and so now we have this whole block right here. So here is my KEW, and I'm subtracting it from my input. Now I'm going to take this and multiply it times this transfer function. So I'm going to come in here and make a transfer function. And I have a 1 over RA plus S. So this is going to come in here, and I'm going to wire this up. Okay, so now we got to come and get some of our variables. So we're going to come look up on our thing. So we come over here. And now we have a KE that is equal to 0.1423 and RA which is 0.7 ohms, and a KT which is equal to 0.15, and we have an LM that we're going to actually use this time, which is equal to 1.7 millihenries. Okay, so then we see our transfer function here is going to be 1 over our RA, which is 0.7, plus our SL, which is 1.7 times 10 to the minus 3s, and we see that our KE is 0.142. So we can come over here, we're going to make this KE 0.1423, and let's make this a little bigger so we can see it. This one is the 1.7 e to the minus 3 and 0.7. Make this bigger. Make sure that so we have 1.7 e to the minus 3s plus 0.7. Okay. So now we're here. And so then this point right here is going to be equal to our current. So now we're ready to move on to our torque. So now if I come down here, so keep moving down. So now we're ready for our motor torque. So our motor torque is going to be equal to KT times I. So again, we're just multiplying it times a constant right here. So we're going to come over here and add another gain module. So this is gain. So we're going to plug that in right here. And we're going to call this KT. And this has a value of 0.15. Make it big enough to see it. And then we might as well start. And so then this value right here is our current. Okay, so now that we have our motor torque, now we come back and now we're ready to add the next thing. So where do we go from our motor torque? So our motor torque, we're after our net torque, which is going to be our motor torque minus our load. So this is going to be equal to our motor torque minus this, which was M times G times R. So this is equal to M was 100, G is 9.8, and our R was 10 millimeters, 0.01. So we come over here and we have 100 times 9.8 times 10 millimeters, so 9.8. So I'm going to add in, now we're subtracting that off, so we want to type in sum. And we're going to come put that right here. And this is going to be a plus and a minus again. This doesn't like this. There we go. Okay. And now this is a fixed torque. So we just want to subtract off 9.8. So now this isn't a gain, this is a constant. So we're going to do a constant, and it has a value of 9.8. And then we are just going to subtract that off. We are going to call this our load torque. Okay, so then this right here is our net torque. So now we're ready for the next part of our equation. Okay, so now what do we get? Now our next equation is that our net torque is equal to J times alpha, so our inertia, and we're going to change this to d omega dt. And again, you can see that this right here is our output. So we want this to be an output by itself, so we're going to take our net torque times the 1 over J to bring that over, and this is equal to S times omega, which is our output. Now we want our output by itself, so we're going to bring the S over. So we have T net times 1 over J times 1 over S is equal to omega. So we see here that this is a gain, And this is a transfer function. So now let's go back over to Simulink and add those in. So the first thing we're going to add in is our gain. And this gain is a 1 over j. Oh, we need to get what our j is. So we're going to come back over here. And our j is going to be the weight part plus our motor. Okay, so we can go and look up our motor, and the j of the motor is equal to 7.062 over 100 squared, because it was in centimeters. We want it in terms of millimeters. So 7.062 times 10 to the minus 4. And then we also have the j of the box, which is going to be mr squared. So that's going to be 100 times 0.01 squared. And that's this right here. Apparently I calculated earlier. And so then this is going to be equal to 0.01 kilogram meters squared. So our j total is equal to the sum of these two. So we have 0.01 plus 7.062 e to the minus 4. So this is equal to 0.0107. And so you see that this part here is our gain part. So we come back over here, and this is our gain piece, which is our 1 over j. So this is 0. Oh, we want 1 over the gain. So we want 1 divided by 0.0107. So we're going to come back to here and put that gain term in there. And this is 1 over j. 1 over j. Okay, and then we have to add in our transfer function here. But this one is going to be equal to the 1 over the s. Okay, so now this point here should now be equal to our omega. Well, our omega had to feed back to here. So now we have to take this point and wire it back to here, because this is our omega right there. Now, we want to convert this to velocity, so we might as well convert this to a velocity using another gain term. So we just multiply it by our r. Which was 0.01. Okay, and then we're just going to add on our scope so we can see what everything looks like. And let's take a shot at this. And so you can see that we speed up until we get to a certain point, way faster than 10 seconds. So let's go and change this just to 2 seconds. And rerun that. Okay, so you see that we're starting to speed up here, And then as we approach our speed, it starts to slow down. Now we can come in here and we can right click here and signals and port. We can add another port if we wanted. And we can say, oh, I want to look at what my current looks like. So I can come over here and grab my current. And so now I have the current down here, or I have the current right here, and here is my torque. Now this one, it's hard to see with this scaling. So we're going to go ahead, change this to 1. And we're just going to add another scope on just for my current by itself. So then we run this. And so you see now this is the current. So you can kind of see that the current kind of ramps up, and then my current starts to drop off as I start to lose my torque. And if we wanted to, we could add another scope. Let's see, we're after our motor torque. So you see we can come up here. And so you can see this is my motor torque, which is right here, which is directly related to my current. And if we wanted to see what our net torque is, you see I can put it right here. But that's just subtracting off a constant, so we can see how everything is running. Now, if we want to zoom in on what's going on at the beginning, we can kind of change this to a 0.1 and rerun it. And then you can kind of see as it kind of charges up, but it doesn't go up instantaneously because we have our inductance now.